All right, we're going to handle greatest common divisors now. So suppose we're in a domain and let's say we have two elements in R, not both 0. A non-zero element D in R is a greatest common divisor if, well, the same definition as we had with the integers. 1, D divides A and D divides B. And 2, if we happen to have another divisor of A and B, say E, then it divides D. Great. So that's what a greatest common divisor is. It's important that it's a greatest common divisor. In particular, we have the following theorem, which we'll prove in this video as well. And the theorem says that if R is a domain and A, B, and R are not both 0, and the greatest common divisor of A and B exists, I'm going to call it D, then any associate of D is also a GCD. So let's go through the proof of that. All right, so suppose A, B, and D are as in the theorem statement, and let's take a unit. Let's let U be a unit, and let's let D prime be UD, so that we have an associate of D. Great. Well, since D divides A and D divides B, there exists some, I don't know, M and N in R, such that A is MD and B is ND. But then A is M U inverse UD and B is N U inverse UD. And in particular, that's a ring element times D prime, and that's a ring element times D prime. So this tells us that D prime actually divides A and D prime divides B. So when we multiply by a unit, we have access to the multiplicative inverse, and that gives us the divisibility we want. Now suppose for the second condition that E divides A and E divides B, we show that it must be the case that E divides D prime. That's the second condition for being a GCD. Since D is a GCD of A and B, we know that E divides D because it satisfies that largest condition. So there exists some, let's see, we've used M and N, let's say K in R, such that D is EK. Well, let's multiply through by U, and we have a domain, so we can alter the order however we like. The left-hand side is D prime, and the right-hand side is E times something. So E divides D prime. And that's it. So it is a greatest common divisor when you multiply by a unit, and it's actually a fact that I'm going to have you prove. So exercise if D, let's write it like this, is a GCD of A and B, and D prime is another, in a domain, then D and D prime are associates. So all GCDs, they're not necessarily equal, because units will cause you to create different GCDs, but all GCDs happen to be associates, which is a converse to the theorem that we just proved.